Okay, lesson 13. Section 3.1 is on graphing linear equations. Of the form y is equal to mx plus b. Okay, before we get started with that, we'll get to that in a bit. We want to get familiar with the concept of an equation in y and x and how it relates to a graph. Here I'm going to ask you to determine which ordered pairs, and I'm going to give you 4 of them, satisfies the given equation. The equation I'm going to give you is not of this form yet. We'll get to a form like that in a bit, but I'm going to give you a linear equation, an equation of a line in a different form. 3x minus 2y is equal to 4. And over here I'm going to start giving you some ordered pairs. I'm going to do 2 together with you, and then I'm going to give you 2 to do on your own. Two comma 1 and 1 comma 4. We'll do them one at a time. And we're seeing if that ordered pair satisfies this, meaning if you plug in the x and the y into this, does the left side equal the right side? Does it satisfy the equation? So for this point, our x is 2, our y is 1. Our equation is this. I'm going to copy it down. That's not necessary, but it'll be a good habit here, at least, especially at the start, so I can literally see what I'm going to plug in for x and what I'm going to plug in for y into this equation, leaving everything else in place. So when I do that, I'm going to have 3 times whatever I plug in for x minus 2 times whatever I plug in for y is equal to 4. So I'm really following that format and just substituting in place of x and y, 2 for x based on that, and 1 for y. Okay, so we've done that where we substituted in values for variables, but now we're going to see if it satisfies it. We also did this for checking solutions, but all right, 3 times 2 is 6. You follow PEMDAS as usual. Minus 2 is equal to 4. 6 minus 2 is equal to 4. So the left side does equal the right. That works out. And so right here I'm going to put yes. If you're printing out your homework, you can circle the ones that apply, that satisfy it. I know what you mean. Okay, let's do this one. Three x minus 2y is equal to 4. The same equation, a different point. X is 1, y is 4 for this one. So x goes there, y goes there, and let's see what it works out to. 3 times 1, 2 times 4. Watch your negatives. In this case, just the 1 minus sign, so it's going to be negative 5 is equal to 4. Is that right? Okay. So that's a no. You get 2 values that are not equal, so this point does not satisfy the equation. Okay, I'm going to give you 2 more. I'm just putting right here. Next one is going to be negative 2 comma negative 1. Watch all those negatives. Last one will be 0 comma negative 2. Also watch those negatives. Okay, pause it here. I want you to work it out on your own. I'm going to erase over here because I'm going to do a graph afterwards. Okay, I'm going to start. I'm going to do less steps as I go along. I'll usually I'll put the parentheses there. That's the way I usually do. 3 times x minus 2 times y is equal to 4. We've got a negative 2 for x, a negative 1 for y. It's going to give me negative 6 plus a positive 2 which simplifies to -4. That's not the same. -4 and +4 are different numbers. Don't be fooled by that. That's a not equal to. That's a no. Last one, 0, -2. Zero for x, -2 for y. 3 times 0 is 0. Here I have two negatives. -2 times -2, essentially it's going to give me a +4. And so I'm going to get 4 is equal to 4. Check. That does work. That's a yes. Okay, now let's talk about the graph of a line. Here we're going to do the graph of the equation 3x minus 2y is equal to 4. The graph of that equation is a set of all points that satisfy it. And there's many, there's infinitely many, but I know two of them. I know that one satisfies it. So let me do my axes first. Okay, so 2, I'm going to graph it in red. 2, 1 I know satisfies it, therefore that's going to be a point on that line. That's part of the graph of it, just one of many, infinitely many points. I know 0, -2 is also on it. Okay, and there's many others that I didn't list or don't have time to list, but basically the points, you don't have to write this down, but there's all these points that do satisfy it. There's a point there, there's a point there, there's another point there, there's another point there. And basically if you do all the points, they form this line. Now, these I just made up. The two that we verified for sure are that one, so I'm going to emphasize it, and that one, 2, 1. But be aware when you draw a graph of any kind of curve, a circle, an ellipse, or a line will do mean a lot of, this line is made up of infinitely many points. These are all points that satisfy that equation. If you plugged in the coordinates, it would satisfy it. It would be a yes. I'm not going to draw like that, but that's the idea. This is composed of infinitely many points. These 2 points just happen to be examples that we happen to work out. Okay? Anyway, that's what it means to satisfy the equation. It means those points will lie on the graph of that equation. What's the deal with that 1, 4? Nothing. It's just a stray point that is unrelated to the line. It's just off the line right there. Not related, it does not lie on it because it does not satisfy it. -2, -1, that's over here. Yeah, they're just straight points that have nothing to do with this because they did not satisfy that. Okay, and then next we're going to start working with slope-intercept form. Okay, next we're going to talk about that equation at the beginning. Has a name, it's called slope-intercept form of a line. And that's the form y is equal to mx plus b. Back in lesson 4, we talked about a linear expression. Linear is coming up here where it's lines, basically. And I said a linear expression was don't write this down. A linear expression was an expression of the form ax plus b, where you have some coefficient times x plus b, or sorry, plus a constant term like 2x plus 3 was a linear expression. Here they just change the letter and they use m instead because m is a standard letter or the customary letter they use for what is called the slope. And that is, note, the coefficient of the x. The b represents where the line will cross the y-axis. Now, a y-intercept is always a point, so I'm going to write 0, b. So whatever that constant term is will be the y-coordinate of the y-intercept. The first coordinate has to be 0 for y-intercept. We dealt with it last time. Okay, and to get us used to this, or get familiar with these, for now we're just going to do an exercise where we find the slope and and the y-intercept of the given line. So I'll give you an equation. Y is equal to 2x plus 3, like that linear expression I just threw at you. There'll be a blank for slope, and there'll be a blank for y-intercept. And what you're looking for is this form, y is equal to, and a linear expression, some coefficient times x plus some constant term. And once you have it in that form, you can pick out the slope being the coefficient of the x, and the plus b, the constant term, becomes the y-coordinate of your y-intercept. Make sure you give your y-intercept as a point. Don't just give me a number here. It's going to be an ordered pair. Your slope is just a number. Your y-intercept is an ordered pair. So make sure you do that. Okay, what's our slope? Well, first of all, let's note the y is by itself. Y is equal to. Y is equal to. And you have a linear expression, something times x plus something, 2x plus 3. It's in that form. Coefficient of the x is our slope, so it's just 2. Slope is just a number. Could be a fraction, could be a real number technically, but early on it'll just be like nice whole numbers or maybe fractions. Okay, the y-intercept is 0 comma something. Let me put that in. It's always got to have 0 as your first coordinate. The second coordinate is whatever the constant term is, plus b. Right there, 3. This line has slope 2 and y-intercept 0 comma 3. Okay, and that'll be useful for graphing it when we do. We'll talk about that later. For now, I just want you to be able to identify it and also manipulate equations to get it into that form. It's going to get a little bit trickier. They're not going to give it to you as nicely as that last example. Don't write this down. I'm just copying down my slope-intercept form for reference. Next one, y is equal to 5 minus x. Think about that one. It's not as easy as the last one. I'm going to make a note. I'm going to mention that your slope is not 5. You don't just take the first number on the left and store it as your slope and take the second number and throw it as your y-intercept. Your slope is the coefficient of the x, and the terms might be written in different orders, and you have to be able to adapt to that. Okay, so the slope is, again, the coefficient of the x. Here's the x. What's the coefficient of it? What's the number in front of it? It's not the 5. It's 1. Or technically, with that minus sign there, that's a negative 1. We dealt with that back when we did lesson 4, expressions. I talked about coefficients. And if you don't see something there in front of the variable, it's an invisible 1. And if you have a minus that term, that negative is part of that coefficient. So that's a negative 1. As our slope. Y-intercept is 0 comma something. It's whatever the constant term is, and the constant in that expression is the 5. The 5 is your y-intercept. You can think of it. You don't have to. If you can identify that, you're good. But if you really want to think about it and understand, you need to have it in this form of some coefficient times x plus something. And what you have to do is rearrange these terms so the x is out front. And when you do that, that minus is attached to it. It goes with it. So it's going to be negative x. And that 5 is just a plus 5. So this is just switching the order of those two terms. The negative goes with that x, and you have a positive 5 added on to that. And then if you want to throw in the imaginary 1 that's in front of it so you can see it clearer, that's the way we're interpreting it. You don't have to rewrite it this way. You have to be able to look at that at least and identify that your coefficient is negative 1, and your constant term is a 5. Next one, we're going to get trickier and trickier. Here we have y is equal to negative x over 2. It is a line. You do have the y by itself, so we will be able to think of it that way. Now one thing is, we have to be able to think of it as something times x, this piece. Let me mention this. Whenever you have a fraction, this is a different problem, like that, and you want to separate out the x and see it as a coefficient times x, you're just pulling this x away. You're just going to pull it out front. And the fraction that you're left with is whatever number is up top with that x is going to stay there, and whatever number is on the bottom, and you get a fractional coefficient. Okay, so similar to this. We're going to pull the x away. It's going to end up there. And right here we're going to have a fraction. It'll be a negative fraction. Then I got to figure out the numbers that make up that fraction. And it's based on the numbers that were in the original fraction expression before I pulled away the x. What number's on the bottom of that fraction? The 2. What number's on the top? That was the coefficient of the x essentially. What's the number here after we pull away the x? There isn't one. It's like that same invisible 1. So when we pull away the x, we get a 1 there. Negative 1 over 2 times x is equivalent. We did it before where we took expressions, but this is not part of it, but we did problems like this before where we crammed it together as one expression. If I want to put this together as one fraction, I would put this over 1. I would multiply the top, which is the 1 times x now. Multiply the bottom, which is the 2 times the 1. And that negative would carry over. So that's me taking that expression, negative 1/2 times x, and cramming it together as one fraction. The x ends up on top, the 2 stays on the bottom, the negative's still there. We get negative x on top, 2 on the bottom. Here we're doing the reverse of that. We're taking that negative x over 2 and splitting off the x from the fraction. Anyway, make sure you can do that and understand it. So negative 1/2 x, we need a plus constant term, and we don't have one. But that means that you can think of it as plus 0. So that original expression, y is equal to negative x over 2, can be written in that way, where we see a coefficient times x plus some constant term, which happens to be 0. Okay, once I have it in that form, it should be pretty straightforward, but it is tricky to interpret it or rewrite it in that form. My slope is a coefficient of the x, negative 1/2. You will have a lot of fraction slopes. What's the y-intercept? It's 0, comma b. And that b, the constant term, happens to also be a 0. So 0, comma 0 is the y-intercept. That line will pass through the origin. Okay, last one. I'm going to put it up here because I need a lot of room for this one. (2x plus 4y is equal to negative 6). Now, the slope is not the coefficient of the x in this situation. It's not 2. Your slope is not 2. Why? Because we don't have it in this form. Your slope is the coefficient of the x when it's in slope-intercept form, and we don't have the y by itself. So what we need to do here is get the y by itself. And we did that in lesson 6, solving an equation for the given variable. And here we want to solve it for y, so we get y by itself, and your expressions with x there. So that it matches up with that. So we're just solving this equation for y. We have this plus 4y. That's multiplication. To get that y by itself, we're going to be dividing by 4. But not yet. We do tend to, I mean you could, but my way is you get everything else other than that 4y. You isolate that 4y, you divide by that 4 as the last step. So instead, let's get rid of all the other terms to the opposite side. Negative 6 is fine. This negative 2x I want to subtract from both sides. That's going to cancel. I'll be left with 4y there. And then here it's going to be negative 2x added to a negative 6. They're not like terms, so you can't combine them. And you can put the different order. You can put the negative 6 minus 2x. But the reason I put it in that particular order is because I am trying to match it up with this precisely, where I have the x term first and the constant term second. Technically it doesn't matter. You could just deal with it in the opposite order. But I'll stick with it where we get a clean answer at the end. I'm not done. I'm going to get the y by itself. Here I'm going to divide by 4. Now, when we solve the equations for a given variable, I said you could just divide that whole side by whatever number you're trying to divide by and just leave it like that. But here I do want to be able to see individual terms. So instead, and I mentioned you could do this, and here I definitely want to do it. Dividing the entire right side by 4 is the same as dividing individual terms by 4. So I'm going to go with that method. The 4 and 4 cancel, so I'm left with y is equal to. Perfect, that's exactly what I'm going for. Y is equal to something. And then the x here can be pulled out, and what I need to do now there is just reduce that fraction, which is just negative 2 over 4. So you're reducing fractions. 2 goes into both 2 and 4, so I'm going to get a 1 on top, a 2 on the bottom, and I still have that negative there. So it is negative 1/2 x. This time I do have a constant term, so what do I get when I reduce negative 6 over 4? It's going to be a minus. A 2 goes into both 6 and 4, so I'm going to get a 3 on top and 2 on the bottom. So I'm just reducing fractions. Okay, and that's the form I wanted in. That's slope-intercept form. So I have to solve for y to get in that form. And now, when it's in that form, your slope is the coefficient of the x. Not at this stage, but here, you're good to go. What's your slope? Coefficient of the x, when it's in slope-intercept form, negative 1/2. What's your y-intercept? It's 0, comma, the constant term, and here the constant term happens to be a fraction, negative 3 over 2. And that's it. Again, you will have fractions coming up, and you will have situations where you want to get this information, slope and intercept, but you need to solve for y first. So be conscious of that. Okay, I'm going to pause it there. Okay, next we're going to start graphing lines. And we'll do it similar to the way I did it at the beginning, where we're going to just plot some points, to get some points that satisfy the equation. So this is one of the more basic ways to graph any equation, not just lines. Graph the given line by plotting points. So I'm going to go through several techniques for graphing lines. And this particular homework, homework 13, will specify which method I want you to use. So there'll be a whole section on plotting points. There'll be a different section on using slope and intercept. There'll be a different section on using intercepts. And you just follow those instructions. Later on, next homework and later on, I won't care which method you use whichever method you're comfortable with. And it's usually slope and intercept is usually the best way. But we're going to go with this basic way. By plotting, what did I say? I was talking about techniques, but I didn't mean to write that. By plotting points. Okay, so here we have y is equal to 3x minus 2. You're going to be provided with a graph, and if you're doing it without, if you're not printing it out, you have to draw. And draw a big one. Don't make those tiny graphs. I want you to understand the detail in it. You're trying to use your homework to learn, not just to satisfy and get those points. So it's important that you know where you place things. And if you're using line paper, still place a tick mark so I know that where those marks are. You don't have to label them. I'm assuming, if you, for now, we can assume that every tick mark you place are just 1 spaces apart. 1, 2, 3, no need to label them. Only label them if you're jumping, but not for these exercises, we're not going to be jumping. Every tick mark represents 1 unit away. Okay, how are we plotting points? Well, you're going to be making a table or maybe given a table. I had you do this in homework 6 where I gave you some x's and gave you some y's and you found corresponding other coordinates. That was a preview of this. And for this homework, sometimes I'll just give you some x's to start off with. Let's say I did that. 0, 1, and 2. They tend to want 3 points. I'll talk about the y later. And what you want to do is you want to find the corresponding y that satisfies this equation. And the way you can do that is substituting x. You did this before. You plug in the x is equal to 0, and you solve for the y, and that'll be the y that corresponds to it. So I'm going to do the work here. This one's pretty straightforward because we're looking for the y, and in order to be y is equal to whatever we get when we simplify. So I'm going to plug in the x is equal to 0. 3 times 0 is 0, minus 2 gives me a negative 2. So negative 2 goes there. That's going to be a point on our line. Plug in the x is equal to 1 and solve for y. In this case, solving for y just means simplifying the right-hand side. 3 times 1 is 3, minus 2 is 1. Okay, and technically that's enough to graph your line because it's a line. So 0, negative 2, make sure you know where that is. Again, whenever there's a 0 coordinate, people end up placing it on the wrong axis. It's 0 along the x, so you don't move along the x, negative 2 along the y, it's right there. 1 comma 1, 1 up, right there. And right there's our line, you just draw a line straight through it, and technically you'd be done. The reason they often make you do 3 points is a checkpoint. And it's sort of to catch your mistakes. If I do that last one and I get a point way over here, and they don't really form a line, it doesn't mean this is not a line, this is definitely a line. It means I messed up on one of those and I would go back and check it. So these all should line up, and if they don't, you have made an error somewhere. So that's what the third point is for, just double checking that these are correct. Alright, I'm going to plug in 2. It's going to be 6 minus 2 is going to be 4. So 2 comma 4 is my third checkpoint. 2 comma 4. Alright, and they do look like they line up, so I feel confident that I haven't messed up any of those points. And that's a technique of plotting points. I can plot a fourth one, a fifth one if I wanted to. I don't have to for lines. So I'm done. I'm going to erase my work here. No, I'm just going to erase this whole thing. Same instructions. But different line. And we are going to have situations where you have fractions to deal with. And let's get a jump on that right away. Here we have fractions to deal with. Okay, I mentioned sometimes they just give you the x's to use. Sometimes they just give you a blank table and you have to pick your own x's. So we'll pick some x's, then plug it in and find the corresponding y, and then plot those points and graph a line through it. Nothing is new other than the fraction, but that does make it an issue. Oh, and the other thing is that we're picking our own points this time. Okay, this is the old line, so it's new computations we gotta do. Alright, don't write this down because it's gonna go badly for us. But a lot of times people just use 0, 1, and 2 as default. You don't want to do that. So this is gonna be bad. Oops. Y is equal to 2/3 times x minus 1. I'm going to plug in the 0 first. So I'm going to start working these out and showing you why it's going to go badly for us. 2/3 times 0 is just 0, minus 1 is negative 1. So I get negative 1. That's actually not bad. In fact, I'm going to keep that one. But I'm going to do the next one. Y is equal to 2/3 times x minus 1. So I'm going to plug in x is equal to 1. And I got to simplify that. I want my y, and I get that by simplifying here. 2/3 times 1 is just 2/3, but then I'm subtracting this 1. And when I subtract a fraction, I need to use a common denominator. So I'm going to rewrite that 1 as a fraction. I need a common denominator of 3. So you can see what I mean. Like, I don't want to have to do this. This is ugly. So I'm going to do 2/3 minus 3 over 3. It's going to be negative 1 over 3. 1 comma negative 1 over 3, sorry, 1 comma negative 1/3 is my second point when I use these x's that I chose, and it's doable. This is valid, but it's going to be hard to graph it. It's going to be 1 and 1 negative 1/3 is about there, and I could work with this, but I'm going to backtrack and just talk about a better way to avoid fractions. So this 1 led me to a fraction. This 0 didn't, so I'm going to keep that 0. But the 2 is not going to go well as well. The 1 and the 2 will not go well. They'll have fractions and common denominators for us to deal with. So I'm going to talk about a strategy for picking these. What you want to pick is things that when you plug it into here, it'll cancel with that denominator of 3. And what's going to cancel with that? Any multiple of 3. A 3 will cancel with that. A 6 will. A 9, a 12, a negative 3. any multiple of 3. So I'm going to put that in your notes. I think you can see it, but I'm going to say when you have a fraction slope, as a strategy to avoid fraction y-coordinates, pick multiples of the denominator in that fraction, in this case 3. Multiples of 3 are like 3 times 1, 3 times 2, 3 times 3. Like I said, 3 works. 0 is also a multiple of 3. 0 is a multiple of any number, so 0 is always a good one, but I want to go to 3, maybe 6. I could try negatives if I want as well. I'm going to do 4 points just for the hell of it. But these are the points that will work out nicely to have nice whole number values, because all of these, when I plug it in there, will cancel that 3 and get nice whole numbers. So let me just work out all these 4 points. It still involves a little bit of fractions, but not common denominators, because at first multiplication it should cancel it. So I'm going to plug in 3 there. That's going to be 2/3 times 3 over 1. The 3's cancel. I'm left with 2 times 1 over 1 times 1, so that's just a clean 2. Don't forget about that minus 1. And I get positive 1. And it's easy for me to graph points that don't involve fractions. Okay, I'm just going to do it up here. Sorry, I'm all over the place. That's my 3rd point, my checkpoint, but I said I was going to just do 1 more for the hell of it, so let me just do that one as well. Okay, plug in the 6. It's going to be 2/3 times 6 over 1. That's why we need to learn fractions. It's going to cancel the 3 and the 6 is leaving me with 2 times 2 up top, 1 times 1 on the bottom. It's going to give me a 4 minus 1. Gives me 3. 6 comma 3 is a point. Sometimes you can't fit them, like my graphs are not too big, and so you got to pick some values that you can see. That 6 and 3 is not actually on this graph. I think it'll fit on your graph, on the printed sheet at least, but it's a little bit big for me. The -3 will be worthwhile for me to do, but be careful about the negatives. It's going to be 2 over 3 times -3 over 1, and I'm going to subtract that 1 afterwards, but that's multiplication. The 3's are going to cancel. I'm going to be left with a -2, minus 1, and that gives me a -3. Okay, so it's much easier to graph nice whole number coordinates. 0, -1, right there. 3, comma 1, 2, 3, right there. 6, comma 3. Way up here somewhere, off my chart, but that's why it's good that I did this extra one of -3, comma -3. Down here. Okay, a little bit bendy, but that's just my hand-drawn graph. Okay, so that's a key thing when you're given fractions as your slope and you want to do these plotting points. It helps you to pick your points strategically by choosing something that's going to cancel the denominator and give you whole numbers, and that would be multiples of that denominator. Okay, I'm going to pause it here. Okay, next we're going to learn how to use slope and intercept. And we'll have a formula for it later and do some computations involving slope in the next section. But here I just need to get one concept down. And that's the fact that we can interpret slope as rise over run. So oftentimes we'll say rise over run. Rise meaning how far you're rising, which could be dropping. Rise is up or down. Run is going to the right. Pretty much for simplicity, I'm always going to stick with moving to the right, moving from left to right as I do my graph. So when I have a slope of 2 over 3, the 2 is my rise, so that means I'm going up 2. The 3 is my run, so I'm going to go to the right 3. Again, always to the right. So on my graph, if I have a starting point, let's say it's right here, and I want to figure out how I'm going to use the slope to find another point, I'm going to start at that point and count 1, 2 up, and always to the right, 3 to the right. I'll get a second point, which is enough for me to draw my line. So I'm going to be graphing lines using slope and intercept. This is how I'll be using the slope, specifically counting rise and run. As a different example. If I have -3/4, even though the negative's outside, applying to the whole fraction, I'm going to think about that as the negative I'm going to attach to the top. So I'm going to think of it as a -3 rise. And that means down 3. That's the opposite of rising. And +4 is my run. So again, I'm going to take that negative and attach it to the top and think of it as a negative rise, but I'm always going to have a positive run. So I'm always going to go to the right. There are other ways to do it, but I think it's going to be more confusing if I start mixing it up, so I'll just be consistent with this. A negative slope is going to be down and over to the right. A positive slope is going to be up and over to the right. I'm always going to be going over to the right for my run. All right, let's see how this works. Okay, so both of these require you to have a starting point. And we'll talk about that later, but for now, let's say I know a point on the line, it happens to be there, and I want to find a second point to draw this line, to graph this line. I'll start at that point, and I'll go down 3, like I said, but over the right 4. And that's how I'm going to draw that line for a slope of -3/4. Okay, I'm going to erase this. Yeah. And let's look at some problems. Graph the following lines using slope and intercept. So this is a very specific technique I want you to use. Again, this homework is going to specify which technique to use for different problems. The last one was by plotting points. This one is by using slope and intercept. I'm going to use the last line that we just dealt with, where we plotted points and it was kind of a pain because we had to choose our x's strategically to avoid fractions. But here it's not going to be so bad. I don't really have to stress about it. Now, on this problem, you're just going to be given that equation, the instructions to use slope and intercept. And that's it. Going from there and graphing your line. And all you need to graph a line is 2 points. You don't need 3 like a checkpoint. Just 2 is enough. But we got to get those 2 points. One thing that's going to help is, I promise you, everybody's going to want to avoid this and just kind of just jump and start graphing things. I would, even though it's not asked for, I would be really careful to pick out my slope and pick out my y-intercept from that equation. So let me do that first. With my slope, first make sure it's in this form y is equal to mx plus b, meaning the y is by itself. My y is by itself, mx plus b. So my slope is 2/3. What's my y-intercept? It's 0 comma something. And it's my constant term, that negative being part of it. It's 0, -1. Okay, and to use the slope like I was talking about, I need a starting point. Right there, I know that point's on my line. That's where my line's going to cross the y-intercept, or the y-axis rather. The y-intercept, 0, -1. I'm going to start with that point. That's my y-intercept. That's using my intercept. Then I need a second point to draw my line through. I shouldn't put that coordinates there. Let me move it over here. You don't need to label it. I'm labeling it for notes only. And then from there, I'm going to find a second point by starting there and counting my rise or run. Be aware, some people mistakenly start from the origin and count 2 up and 3 over. I'm not doing that. I'm starting here, starting at this point. And I'm going to go 2 up. So that's my rise. And then 3 over. You don't have to label things with rise over run. I'm just showing you for your notes. 2 up, 3 over. And that's it. And that's the exact same graph that we did earlier about plotting points. In fact, that was the other point that we got. That was one of the 4 points that we used. Anyway, that's how you're going to use slope and intercept. I'm going to give you another one to do. I'm going to erase here. I'll leave that up, but it helps you to pick out your slope and intercept first. That's the main thing. And this one's we're going to start getting tricky. (4x plus 2y is equal to 6). I'm going to leave a little space here for some work because you do have some work to do. Your slope is not 4. No. Why is the slope not 4? Because it's not in slope-intercept form. You don't have the y by itself. So eventually I'm going to identify my slope and my y-intercept, and once I do, I'll start at my y-intercept and then count my rise or run based on my slope. But I need to solve this for y first. So I got to get the y by itself. In fact, I think I didn't leave enough room for it. It's going to take a few steps. I should erase this. I'll draw it in after I'm done solving. But anyway, let's get the y by itself. Think about what you're going to do first. You got to get rid of this 2 eventually, but that's later. You divide by 2 as the last step. I want to subtract the 4x from both sides. Move all the terms to the other side from the y. Leave the coefficient of the y there for now. And if I want to have it as literally mx plus b, I'll put my x term first and my constant term second. Technically it doesn't matter though. Okay, what's the next step? Now you're ready to divide by 2. You want to get the y by itself, you're almost there. You just don't want that 2 there, so you're dividing because it's multiplication. And instead of dividing the entire right side by 2, I'm going to do what I did before and divide individual terms by 2. All of them, though, every single term gets divided by 2 when I do this. I'm going to get y is equal to, reduce that negative 4 over 2, gives me negative 2 times x. Reduce that 6 over 2, watch for negatives, but that's just positive, so that's plus 3. That's your slope-intercept form of this line. You have to spend some time getting there. But once you have it as y is equal to mx plus b, then you can pick out the slope as the coefficient of the x. Again, you can't grab the coefficient up there because that's not the correct form. Negative 2 is your slope. Your y-intercept is 0, 3. Okay, so like I said, your slope is a number, sometimes a whole number, and your y-intercept is a ordered pair, a point. Now, let's talk about that slope. I should have wrote it over here. Let me just rewrite it over here. I'm going to think about it as rise over run and graph it using slope by going rise over run. And to do that, I need to see the top, the numerator, and the denominator, the bottom. So I need it as a fraction. And if you have a whole number here, you need to interpret it as a fraction. So your slope is technically negative 2, but for purposes of graphing, you want to actually put it as negative 2 over 1. And so that's going to be 2 up. Ooh, not 2 up. That negative I'm attaching to the top. So that's a 2 down. That's a rise of negative 2. 1 over to the right. So slope of negative 2 is interpreted as negative 2 over 1. 2 down, 1 over to the right. I'm just going to cram it here. Yeah, is that okay? Okay, you are starting at your y-intercept, 0, 3. Right there, on the y-axis always, 0, something is on the y-axis. And then from there, I count my rise over run. And again, I'm thinking of it as a negative 2 over 1, so that's 2 down, and 1 over to the right always. Okay, and that's how I'm doing it. But you have to solve it for y to get it in slope-intercept form to be able to use the slope and intercept. All right, what else I got? Okay, I'm going to pause it here. And next type of problem. Okay. Okay, next, this is important because it's going to come out later when we start working with application problems, word problems, when we want to find intercepts. We did it on homework 12 where you just kind of point at it and identify and estimate its coordinates. But here you're going to have to do it from an equation. So you're going to determine the x-intercept and y-intercept and use them, because that's 2 points, to graph the line. Now a lot of times, not always, I'll give it to you in a form that's not slope-intercept form. And here's the thing about this, you generally don't want to bother to put it in slope-intercept form in this particular instance. So I'll write it in your notes. Where's my red pen? So for this specific purpose of finding intercepts, oh, and I will say x-intercept, y-intercept. Do you have blanks for them? And for your notes, I'm just going to say no need to put into, or to write as y is equal to mx plus b. Y is equal to mx plus b will be useful when you're graphing via, or using the slope and intercept, because it helps you to identify the slope and intercept. But here we don't need them. We're not going to bother. We're going to identify x and y intercepts. And although that form does give you the y-intercept very quickly, it makes it a kind of a pain to backtrack and find the x-intercept. Instead, we're going to leave it as is. So here's our strategy. My strategy here is going to be first to note that the x-intercept and the y-intercept are both ordered pairs. The second thing I'm going to note is something we talked about in homework 12, which is that we know the form of it. We know each coordinate for an intercept. One of the coordinates is 0. You do have to remember which one. Let me draw you a mini graph. Don't draw this because this is not accurate, but the idea here is when you have a line that crosses both the x and y axis, this is not the actual graph, don't interpret it as that, I'm just a rough sketch for us to remind us that a point that's crossing, a point where it crosses the x-axis will be a comma 0. X could be anything, could be anywhere on the x-axis, so the x-coordinate could be any number, but the y-coordinate has to be 0 because it's not going up and down, it's on that axis. The y-intercept, on the other hand, will be 0 comma b. It won't be anywhere along it won't go left or right, but it'll go up or down, so it'll be on that y-axis, and that first coordinate will be 0. So those are the forms of those two intercepts, the x-intercept and the y-intercept. Now I'm going to start borrowing that. I'm going to say for the y-intercept it's 0 comma something, and for the x-intercept it's something comma 0. Again, this is not an accurate depiction of that equation, so I'm going to erase it, not confuse us. All I wanted to remember is that which coordinate is 0 in my intercepts. Alright. And that's enough information for me to fill in these other points. So I don't know what that is. That's what I got to figure out. The x-coordinate of my x-intercept and the y-coordinate of my y-intercept. And I'm going to treat this like a problem that we did in homework 6. You don't have to write this down, but the idea here is I have that equation and I'm trying to fill in something that goes with 0 there, and something that goes with 0 there. So basically it's use that equation and fill in complete the following table. And what you did there was you basically plugged in y is equal to 0 into the equation and solve for x, and you plug in x equals 0 and solve for y. So that's what we're going to do. So it's like one of that problems. I'm going to erase this, but I just wanted to relate to something you did before. Okay, so let me organize it. You don't have to go through all this every time, but let's do the x-intercept first. For an x-intercept right here, my x-coordinate is unknown, but I know my y-coordinate is 0. So I'm going to go ahead and plug in y is equal to 0. Into that equation, moving everything in place. The x stays x. 2 stays there, and replacing y with 0, it should equal 4. Or I'm trying to find the x that'll make it equal to 4, because that's the points that go together that satisfy this equation. Alright, I simplify from there. I solve for x. 2 times 0 is 0. X plus 0 is just x. But sometimes you gotta solve, moving things to one side and that kind of thing. Anyway, I got x is equal to 4. So when y is 0, x is 4, and that's my x-intercept right there. For my y-intercept, let me start by copying that equation as is. Let me go over here and note that for my y-intercept, I know that my x-coordinate is 0. I don't know what y is yet, but I'm going to solve for y by plugging in x equals 0 in there. Alright, so it's going to be 0 plus 2y is equal to 4. 0 is just gone, so it's 2y is equal to 4. And then I divide both sides by 2. Oh, I should have wrote that in red, sorry. Plug it in, x equals 0 there. Solving for y, and I get y is equal to 2. 4 comma 0 and 0 comma 2 are my two intercepts. From there, I just plot those 2 points and draw a line through it, and that's how I'm using them to graph the line. I got to erase somewhere. Okay, make sure you have that down. Pause it if you need to write that, but I'm going to make space here for the actual graph. Okay, so remember that technique, plugging in, filling in the zeros first, and then plugging those zeros into the equation to solve for the corresponding coordinate. The most common mistake there is losing track of negatives or messing up with the negatives, because they can get tricky. Anyway, 0 comma 2, right there. 4 comma 0, right there. You don't need to label this is more for your notes. Those are my intercepts right there and there. And since I wanted to use them to graph the line, just need to draw a line straight through them and I'm done. Okay, so to recap, what I did was, before I got even started, was just setting up my ordered pairs, filling in the zeros that I know based on any x-intercept has to have a 0 there, any y-intercept has to have a 0 there, and then using those zeros in those equations and solving for the other variable. Okay, one last thing. Okay, this one I'm gonna be careful about. I mean, on your homework you have like nice printed page. You don't have to print it out to do these problems. But I'm saying it'll be in a very accurate, pre-printed form. But to illustrate it here, I gotta be real careful about it. I gotta pretend I have this grid. Yeah, whatever. Okay. Highlighted here, I tried to make it a little bit thicker where the actual axis is. I'll also label it X and Y there. And you're going to begin a graph with a line already on it. Ooh, I got to bend it a little bit because my graph is off. Oof. Okay. I'm hitting all these intersections along the graph. Okay, so I hit right there, right there, right there, right there, right there. It's a perfect 45-degree angle if you know what that means, but if not, I'm hitting all those intersections between the grid marks. It won't always do that, but I'm trying to keep it simple, something you can draw. This is similar to the problem that we did where we had a graph of calories and minutes spent on a treadmill, and you had a graph and you wanted to see how many calories you would burn, and you would go up and find the corresponding calories burned. That thing we did in homework 12 or lesson 12 at the very start. reading a graph related to calories burned on the treadmill, related to minutes spent on a treadmill. This is similar, except it's completely abstract. And also you're going to have to go into other quadrants. That example that I just talked about was off first quadrant, but here we have to deal with quadrant 1, 2, 3, and 4, and the point set in question could be in any of the quadrants, meaning you do have to deal with negatives, and because of that, it does make it a little more difficult. Anyway, those two are two separate problems. We want to find y when x is negative 2, meaning there's some point on this line that has a negative 2 as x coordinate, and I just want to find that corresponding y. My answer is just y is equal to a number, but I'm trying to find what y coordinate corresponds with an x coordinate of negative 2. So I'm going to look on the x-axis and go where x is negative 2, right there. And I want to find the corresponding point on the line that has that x coordinate. So a point that has an x coordinate of negative 2 would be a point along here, or maybe down here, so then you got to find it right there. That's it. So you stay on that negative 2x, which is a vertical line, essentially. Right there. What's the coordinates of that point? Let's verify it. The coordinates of that point are negative 2 and negative 3. That's a point in question, so when x is negative 2, y is negative 3. Make sure you're giving me the actual y value because they wanted to find y. They didn't want to know the coordinates of the point. So you can figure out the coordinates of the point, but make sure you're giving me an actual answer of y is equal to negative 3 when x is equal to negative 2. Okay, I'm going to erase this because you have another problem to do. Think about that one. I don't want to clutter up my picture. It's a completely different point now. This time they're giving you y is equal to 2 and find x. So ultimately you're looking for a point that has blank comma 2. And so you look for 2 wherever y is equal to 2. So that's along the y-axis. Y is 2 is, here's your y-axis. 1, 2, right here. And the points that have y-coordinate 2 is any point over here has y-coordinate 2, any point over there, so you're going along here. And right there it is. That's the point. What are the coordinates of that point? Here's my origin, 1, 2, 3. 3, comma 2. So that confirms it. My y-coordinate is 2. And when y is 2, my x has to be, for that line, my x has to be 3. And that's it. Just reading the graph essentially, but again, more abstract than what you did in homework 12. Okay, that's it for this lesson, I believe. Yeah.